Today's lesson is discussing similar polygons. You know what a polygon is, a closed, many-sided figure. What does the word similar mean? If figures are similar, it means that they have the same shape but different sizes. So we've taken a shape and we've either made it bigger or made it smaller, but we didn't change the shape in any way. So here are two examples, or one example, of two similar figures. They look like they are the same shape, but one is smaller than the other. So don't get this confused with congruent. Congruent is same shape, same size. And remember, we use the congruency symbol. It looks like an equal sign with a squiggle over it. If they are just similar, same shape but different size, then we use just a squiggle. Okay, a tilde. This sign alone, without the equal sign below it, means is similar to. So we can write similarity statements, just like we wrote congruency statements, matching our corresponding parts in our name. So here's how we name similar polygons. If these are our two polygons, you have to make sure that you name the vertices in the correct order when writing a comparison. So if I'm going to name this polygon, I'm going to start with A and go around clockwise. I'm going to say A, B, C, D. I could start anywhere, and I could go counterclockwise or clockwise. We typically go clockwise. My first polygon, it's up to me how I want to name it. But just for simplicity's sake, we're going to go in alphabetical order here, A, B, C, D. Well, since I started in the bottom left-hand corner here, the corresponding part on this other polygon is the W. So I have to start its name here. I have no choice on the second one. The second one has to follow the same pattern as the name of the first polygon. So whereas ABCD was a choice, WXYZ is not a choice. I have to start at W and go around clockwise just like I did on A, B, C, and D. The corresponding parts have to be in the same order. I should be able to look at these names and know that A corresponds with W, that they're in the same position on that figure. B corresponds with X, C corresponds with Y, and D corresponds with Z without having the picture in front of me. I should know that they are in the same position. Okay, so a formal definition of similar polygons would read like this. Two polygons are similar. This if with two F's, that's not misspelled. That's there on purpose. It means if and only if, meaning these are the only conditions that will create two similar polygons. They are similar if and only if their corresponding angles are congruent, so the angles have to be the same, and their sides have to be in the same ratio, and the ratio of the corresponding sides are equal. So if I create ratios out of my corresponding sides, they should all reduce down to the same number. If they don't, our polygons are not similar. So similar polygons, one, have congruent corresponding angles. All the angles in the same position will be the same measure. They have proportional corresponding sides, so I make a proportion out of the corresponding sides, and they should all reduce to the same number. And we would then use our little tilde to mean it is similar to in our congruency statement. Okay, so if I tell you that these two polygons are similar, write a similarity statement. Okay, again, I'm going to go in alphabetical order just because it's less confusing. So I'm going to say polygon or quadrilateral ABCD is similar to, remember our symbol here. Okay, now here's where I have to be intentional. A came first on this polygon name. So E, because these are corresponding parts, has to come first. B was second, so F is second. C third, G is third. D fourth, H is fourth. So my similarity statement is A, B, C, D is similar to E, F, G, H. They have to match up. Corresponding parts in the same position. That tells me that angle A is congruent to angle E. I now can match the parts without even having these pictures. B, angle B is going to be congruent to what angle over here? F. Angle C is congruent to G, and D and H are also congruent. Okay, so that takes care of my angles. Now what about my sides? Okay, well this says that the corresponding sides are proportional. So again, if I go in order here on my name, I have side AB corresponds with side EF. That ratio, that fraction, AB over EF, should be the same when reduced to the ratio of side BC over FG. Let's see, does BC correspond with FG? Yep. So if I make a fraction out of those two and reduce it, it should be the same number every time. So here's what our equality statement would look like. AB over EF will equal BC over FG, which should equal CD over GH, which should equal DA over HE. Okay, so I'm making a ratio out of all the corresponding parts, and when I reduce these fractions, I better get the same answer. If I don't, these are not similar polygons. So let's go through some examples here and see if you can figure out if they're similar or not. Okay, are these two figures similar? First, you need to ask yourself, are they the same shape? Well, yeah, they look pretty much the same shape. Okay, obviously, if one was a triangle and another was a square, we would stop right there and say no. So now we need to go a little farther and ask ourselves, are the corresponding angles congruent? So we're either going to look for numbers or congruency marks. Again, the corresponding parts have to be congruent. So they have to be in the same position with the same congruency marks on them. 1 and 1, 2 and 2, 3 and 3, 4 and 4. So yes, our corresponding angles are congruent. So now the last check is, are the ratios of the corresponding sides congruent or equal? Well, let's set up our corresponding ratios. If I go from small to big, XW, this 3.5, corresponds to what over here? The 7. So I'm going to make a fraction, 3.5 over 7. Then I go around to the next side, 3. What does that correspond to over here? Corresponds to 6. So I'm going to make a fraction or ratio out of those two. Then I work my way around. 2 over 4, 4 over 8. And all of those ratios should come out to the same number. Okay, 3.5 over 7 reduces to 0.5. It's a half. 3 over 6 is a half. 2 over 4 is a half. 4 over 8 is a half. Are all of these the same number? Yes, they are. So are these two similar figures? Yes, they are. You have to have both of these conditions in order to say they are similar. When you have two similar figures, you can set their ratio in a fraction, and we call that a scale factor. Okay? Their corresponding sides make a fraction. It doesn't matter which corresponding side you pick because they all should be the same fraction, right? If they're similar, just pick any of the corresponding pairs, make a fraction or a ratio out of them, and that is your scale factor. Now notice I could say 3 to 2, or I could say 2 to 3. I could go either direction in my comparison. Obviously, if I'm going 3 to 2, I'm getting smaller. I'm comparing the big one to the small one, so I'm getting smaller. I took a large object and I made it smaller. If I go the other direction, 2 to 3, I'm taking a small object and making it bigger. So you can go either way, just know how to read it. Know that if you are showing your ratio like so, 3 to 2, you shrunk. It's a reduction. If you go from 2 to 3, you made it bigger. It's called an enlargement. Okay? And remember to always reduce your ratios when you can. Okay? Reduce when you can. You want whole numbers. All right, so let's do a few examples and then we'll be finished. Determine whether each pair of figures is similar. All right, well, in order to be similar, our corresponding parts, our angles have to be congruent and our sides have to be proportional. So I'm going to start off with these two corresponding parts right here. Are they congruent? No. So right there I can stop and say no, they're not similar because my vertex angles are different. These are, you should have recognized that these are isosceles triangles and that these two marked angles were the vertex angles, even though this one was upside down. Angle P corresponds with angle K. They are not the same, so they're not similar. Okay, let's look at these. Now here I have 80 and 60, here I have 80 and 40. So at first glance you might want to say, well no, because this is 60 and this is 40. But you're not comparing the corresponding parts. You have to be careful. Angle T corresponds with angle C. You need to know what angle C is before you can make that comparison. How am I going to find this missing angle in my triangle? What is the sum of all three of these angles? Hopefully you said 180. Well, right now I have 80 and 60 is 140. So what is my other angle if I need them to add up to 180? That other angle is 40 degrees. Now look, they match. Okay, so now I have to check angle R with angle A. So I got to go back over here and find this missing angle. 180 plus 40 is 120. What do I need to add to 120 to get 180? I need to add 60. So yes. All right, so we're good on my angles. My corresponding angles are congruent. Now I have to make sure my ratios of corresponding parts are congruent. So I'm going to go 3.9, set that up in a ratio with its corresponding point or side 5.2. When I reduce that, I get 0.75. Now we just go around our triangle. 6 and 8 are corresponding. 6 divided by 8 is 3/4, which is 0.75. And then my last two sides, 5.25 over 7. If you divide that out, you get 0.75. So look, I got the same number for each one of my ratios. So both conditions are true. My corresponding angles are congruent. My ratios of corresponding parts are equal. So yes, these two figures are similar. Okay, one more. Determine whether these are similar. Again, we got to fill in some missing parts here. Because I have an isosceles triangle, I know that this base angle here is going to be 76. I'm going to find my missing vertex angle by adding the three angles together and setting them equal to 180. Okay, 76 plus 76 is 152. What's 180 minus 52? 28. Okay, so this is 28. All right, well that matches here. Now I've just got to make sure that these two base angles are 76. How am I going to figure that out? Well, I know that they have to be congruent because it's an isosceles triangle. So if I called those both x, then 28 plus my two x's have to equal 180. If I subtract the 28, I get 152. And if I divide that in half, I get 76. So my angles are congruent. I'm good there. Now I've got to compare. Got to compare my two corresponding sides here. 5 divided by 7.5 and 11 divided by 16.5. Okay, this will reduce to 2 over 3, and this will reduce to 2 over 3. If you get your calculator out, you'll see that. So my corresponding parts are in proportion. So that means yes, they are similar. Now, which similarity statement is correct? Now, let's erase all this stuff so we can see a little bit better. If I name this triangle AXE, AXE, can I name this triangle WRT? Am I matching corresponding parts? Does W match with A? I sure hope you said no. This is a vertex angle and this is your vertex angle. So W has to match with X. So it can't be this one. W and X are matching in the same position. They're both in the middle here. So this would be my correct answer, B. All right. So be able to determine if two figures are similar by confirming that their corresponding angles are congruent and that the corresponding sides are in the same ratio, that they are proportional. And then be able to solve for missing parts if we already know that the two figures are similar. Also be able to write your similarity statements, matching up your corresponding parts.